Hi, welcome back. A buzzer is a device that can generate simple tones, typically used to provide audible feedback to the user. Buzzers are used in alarm clocks, keypads, many household appliances, and simple toys. To show you how a buzzer works with the Arduino, we will repurpose the circuit we used back in lecture 16, where we control the brightness of an LED using a potentiometer. What we do here is to control the tone of the sound emitted by a buzzer using the same potentiometer. We'll just replace the LED with a buzzer. This is what we'll make. We'll need the Arduino, a buzzer, and a bunch of jumper wires. The circuit is essentially the same as in lecture 16. We'll use digital pin 11 to generate PWD pulses that depend on the voltage measured at analog pin 0. This is the voltage controlled by the potentiometer. As the potentiometer generates a higher voltage, the pulses in digital pin 11 have a longer duty cycle and trigger the buzzer to generate a louder, higher pitch sound. When the potentiometer generates a lower voltage, pin 11 generates a shorter duty cycle pulse, which makes the buzzer generate a softer, lower pitch sound. This is the buzzer. It has two pins, providing an electrical pulse through these two pins is going to generate a tone, and I'll be controlling the pitch of the tone using this potentiometer. Start with the potentiometer, plug it into the breadboard, and connect it to ground. And 5 volts power. And the middle pin for output voltage, which will go to analog pin 0. Then I'll plug in the buzzer. Sometimes it's a bit hard to see where the pins have gone, so just remember that I've got one pin in column 22 and the other one in column 25. So one of the two pins will go to ground. Doesn't matter which one it is. And the other pin of the buzzer is going to go to digital pin 11, which is PWM capable. And I'll finally connect the 5 voltage column of the breadboard and the ground column. Okay, the assembly is done, so I connect to my computer and upload the sketch. And as I turn the knob of the potentiometer, you can hear the change in pitch of the sound that comes out of the buzzer. Let's have a look at the sketch now. The only difference between this sketch and the one from lecture 16 is the variable name for the buzzer pin. LED pin is now buzzer pin. Everything else is exactly the same. As an exercise, can you write a sketch that generates noise that covers the full spectrum of frequencies possible for this buzzer? For this, you need to use the loop function, for which you can find information in the Arduino language reference. What you will need to do is to write a loop that counts from 0 to 255, the range supported by the WPM pin, and output this value to the pin where your buzzer is connected. This is what I would like you to make. Okay, this buzzer doesn't have the best frequency response, so playing music through it is probably not a good idea, but still, it is a very useful component.